All right, this is going to be a very quick summary of parallel and perpendicular lines. Just a quick explanation about the slopes of parallel and perpendicular lines, and also how to write the equation of a line that is parallel to or perpendicular to a given line. Okay, so this is something that everyone has kind of had a little bit of trouble with so far, so hopefully this will help you. So these are some examples that we did in class quite some time ago. So parallel lines are two lines in the same plane that never intersect. Perpendicular lines are lines, they don't have to be in the same plane, but you can technically always draw a plane through two perpendicular lines. But anyway, they don't by definition. So they're just two lines that intersect at a right angle or at a 90-degree angle. Okay. So just some basic notes. These should be in your journals already. By definition, again, parallel lines, they have to lie in the same plane, and they never intersect. They have the same slope or identical slopes. And then perpendicular lines, again, they intersect at a right angle or 90-degree angle, and they have opposite reciprocal slopes. So that's pretty much the biggest difference between them, and that's the thing that we're usually most focused on in the equation. Either we're looking for lines that are two lines that have the same slope, or two lines that have opposite reciprocal slopes. So opposite reciprocal means that you change the fraction or change the sign, and then you flip the fraction. So let's do perpendicular first, because that's what everyone seemed to struggle with the most. So the most common error on the actual quiz was that students, they did all the equation correctly and used point slope form correctly, but they didn't change the slope. So these are the examples that we did in class. So I'm just going to quickly run through them again. So here I need to write the equation of a line according to my directions. I need to write the slope-intercept form, which we know is y equals mx plus b. I need to write the slope-intercept form equation of a line that is described. So for number 5 here, the line that's being described has to go through this point, and it has to be perpendicular to this line. So first of all, what they're giving me is my x and y coordinate. And then the only reason they give me the equation of this line is so I can get this from it right here. This is the slope. Notice I did not include x. X is never part of the slope. So I'm given -2 that is given to me, and if I want the equation of a line that is going to be perpendicular to that line, again, perpendicular is denoted by a kind of an upside down capital T. If I want an equation that's going to be perpendicular to it, then I need to first find the opposite reciprocal of that slope. So I'm going to use the opposite reciprocal. So I'm going to change the sign, and then I'm going to flip the fraction. So I'm going to make it positive, and the reciprocal of 2 is 1 over 2. So it's going to be positive 1/2. That's the new slope for the line that the equation of the line I'm going to write. And I have my 2 x coordinates there. So if we have the point of the line we want and the slope of the line, then it makes sense to plug it into point slope form, which looks like this. Y minus y sub 1 is equal to m, which is the slope, times the quantity x minus x sub 1. So there's 3 things we're plugging in here. We're plugging in y sub 1, the slope, and x sub 1, which are given here, here, and here. Okay, so we're going to plug those 3 values in. So when I do that, it's going to look like this. Y minus 2 equals positive 1/2 times the quantity x plus 2. And the reason why I'm changing this to addition here is because there's already a minus sign in my formula, and there's also a negative in front of the x coordinate that I have to use. So if I plug this in, it's going to be x minus -2. So I'm going to go ahead and save myself a little bit of a step, and I'm going to change that to addition. So now the next step is I'm going to distribute, because I need this to look like slope-intercept form. Slope-intercept form, again, is y equals mx plus b. And that looks like this. Slope-intercept form looks like y equals mx plus b. So if you're struggling with that part of it, then I suggest that you get a slip of paper, put y equals mx plus b, line up the equal signs, and then compare it. So I need to get y by itself. Y is not by itself. I need to have the slope and the y-intercept on this side, and I don't see any parentheses here, so there's parentheses here, so I definitely need to simplify and take care of that. So what I'm going to do first is to distribute, and when I do that, that means I'm going to multiply 1/2 times both of the terms inside my parentheses. So this is going to be 1/2 x. 1/2 multiplied with 2 is going to give me a positive 1. Half of 2 is 1. And then I'm going to bring down my left side. So I'm closer. The right side's looking better, but I still should not have anything besides y on this side. So I'm going to take it a step further, and I'm going to get rid of the minus 2 on this side. Now to undo subtraction, we know that we're going to do the inverse, which is addition. Over here, these guys add up to 0. And when I bring down what I have y equals 1/2 x plus 3. So if I compare my equation to the equation that I'm going for, I can see that this is now in slope-intercept form. So this is going to be my final answer. Okay? So this guy right here is the final answer for number 5. And if I were to graph these, both of these lines would pass through -2, 2. Well, this line, not necessarily this one actually, let me correct myself. This line will be perpendicular to this line. They will be perpendicular, which means where they intersect is going to be a right angle, and this line is going to pass through the point -2, 2. And if you can, I know that this point will pass through here if I plug it in. If I plug y in over here, I'll have 2. And if I plug -2 over here, this will be -1 plus 3, and so I'll get a true statement. So if you're not sure, if you know that the slopes are correct because they're opposite reciprocals, and you want to just double check that your equation is actually correct, then just like we've done before, and just like you did on your previous, had to do on one of your previous homework problems, you can plug in 2 for y, and you can plug in -2 for x. And if I get a true statement from this, then this means that this point is on this line. So if I just simplify there using order of operations, this is going to simplify to -1 plus 3, and sure enough, 2 equals 2. So I can just directly compare the slopes of the line that was given and my answer, and I can clearly see that those are opposite reciprocals. So the lines are going to be perpendicular. They're going to intersect, and they're going to intersect at a 90-degree angle because of that. But I also needed to make sure that this line passed through this point, and I just verified that with a real quick check. So this is a way you can check your answer as well. Okay? You don't have to do this part, but I mean, why not? Why not be certain that you are correct? So that's number 5. So let's slide on over to number 6. We're going to do this again. So for number 6, I want, again, a line that is perpendicular to the line that is given, and it must pass through this point. And this is the slope that they're giving me to work with. Okay? So if my given slope is 1/3, and I want a line that is perpendicular to that line, that means that I need to take the given slope and find the opposite reciprocal. And then in this case, it's going to be 3, -3. So the opposite of positive 1/3 is -1/3. And then if I need the reciprocal of that, it's going to be -3 over 1, which is, as we call it on the streets, -3. Okay? So we are going to plug this into point slope form once again. All right. So we have three variables. We have y sub 1, the slope, and x sub 1. So we have those values given to us. So now it's just a matter of plugging it in. My slope is -3, and I have x. Again, I have a negative here, so I'm going to go ahead and change that to a positive. And my goal is going to be to put this in slope-intercept form. So again, if I compare what I have, to slope-intercept form, I'm not there yet. So the -0 here isn't actually doing anything. So we can just basically not write that in the next step. However, I definitely need to distribute on this side. So here I'm going to distribute that -3. So that's going to be multiplying with x and with the +3. So this is going to be -9 here. And I'm just going to bring down that y. What I don't want to see you guys do is add 0 to both sides. I mean, technically you're not wrong, but think about it. If you're adding nothing to both sides, you're also not changing anything. So it's kind of a pointless step. So just put your y there, and that's it. That's our final answer. And again, if you wanted to, I know it's my final answer because it's in that form. And again, if you wanted to check it, you can just compare the slopes 1/3 and -3 are opposite reciprocals. And if I'm not sure if this line passes through that point, well, then I can always just check it. So I'm going to plug in 0 for my y, and I'm going to plug in -3 for my x, because that's the coordinate. And that's just 0. Here I have a negative times a negative, which gives me a positive. And last time I checked, 9 minus 9 is in fact 0. So I know that these two lines are perpendicular because I can compare their slopes and tell that. They're opposite reciprocals of each other. And I can clearly see that it passes through this point with a little bit of arithmetic. And that's that. So as far as writing the equation line that's perpendicular to a given line, that's all you have to do. So let's slide up here to number 1. And just for comparison, go ahead and do one where the line is parallel. Now, everyone pretty much got these right. But since we're making this video, we'll go ahead and do a couple where the lines are parallel just for good measure. So these are even easier. If I want a line that's parallel to a given line, then all I have to do is just steal this slope as is. I don't have to change it because according to my notes, parallel lines have identical slopes. They have the same slope. So I'm actually going to use this slope without changing it. It's going to stay -2. Now when I go to plug this in, I have my x sub 1 and my y sub 1. I'm going to plug this guy in here into my point slope form. Now when I'm learning how to use a formula, or if I'm trying to memorize it, I write it every single time I use it. And after you do enough examples, that thing's committed to memory. So there's a little study tip for you. So I'm going to plug in my three values. So we have y minus 4 equals our slope, which is -2. And I'm going to plug this in here. In the next example I do, I'm going to make sure the signs are different so you guys don't think you always change that to a plus sign. That's just a coincidence with these examples. So for the next one, or next, I'm going to compare this to my slope-intercept form, which is right there. There's my slope-intercept form. Again, I have to distribute and I have to add a term from the left to the right, add or subtract based on what it is. So every single one of these problems is the same number of steps once you figure out what slope you're using. You're going to distribute and add or subtract from the left to the right. So it's really just a straightforward process, and you guys are going to see these problems over and over and over again. So if you can just master them, you'll remember them for your test and your EOC and all that great stuff. So I'm going to distribute. It's going to be -2x, and if I multiply those, that's going to give me a -4. I'm going to carry down my left side, and now I can go ahead and add 4 to both sides. Make sure I line it up in combined like terms. So this is going to give me -2x Oh, and look what happens there. That's kind of neat, isn't it? So that zeroes out as well, so that's our answer. There we go. And you don't have to put plus 0. Okay. That's minus 4. It's negative 4. Huh? It works out. So y equals negative 2x is our final answer. So again, you don't have to put plus 0. If I was going to graph this, I might put plus 0 to emphasize that I'm starting at the origin, but that's not necessary here. And this one's even easier to check. So negative 2, y equals negative 2x passes through the origin, and y equals negative 2x minus 4, they both share the same slope, so they're definitely parallel. And if I'm not sure that this line passes through this point negative 2, 4, then you can do exactly what we did a moment ago, is you can take it, I'm going to plug in my y-coordinate, and then I'm going to plug in my x-coordinate, and if I get a true statement, then that means that that point is on the line, and I know that I did my problem correctly. So there's always a way to check yourself when you guys are working with equations. Some students don't know how, but I'm showing you, so now you do, okay? There's never any reason for you to doubt whether your answer is right if you know how to check your answer, and you can in algebra, which is beautiful. Not always in some of the geometry, but in algebra, yes, you can do it. All right, so let's do one more example. Actually, some of these are weird, so we'll do a couple of examples. So let's look at number 3. That's a weird one. It's a weird problem. So this one, we want a line that's parallel to y equals negative 5, and we needed to pass through 4, 3. So some of you might remember, some of you might not, that when you have an equation of a line that is y equals a number, that means that the slope is actually 0. So if we were to put in the x here, the slope is actually 0 here, which is why this term is missing completely. So the slope is 0 even though you don't see it. So we're going to use m equals 0 there, because that is the equation of a perfectly horizontal line, which means we have a 0 slope. Now here I have my x-coordinate and my y-coordinate, and I'm going to do what I've done in every other problem, is I am going to plug this into point slope form. So here's my formula, and I'm going to plug this in. So this is going to be y minus 3 equals 0 times the quantity x minus 4. Now this one is a piece of cake because I have 0 and I'm distributing it, which means I'm multiplying two other numbers by 0, which is just going to result in 0. 0 times any real number is just 0. Look at that. I'm going to bring down my equation, and then all I have left to do, if I compare it to my y equals mx plus b, I just got to get y by itself. There's no x term there because the slope is 0. So I know that that looks weird, and some of you might be like, what? But that's okay. If the slope is 0, then there's not going to be an x term, and you're fine. So we have y equals 3, and that is our final answer. So if we compare these two lines, both of them are definitely parallel because they're both perfectly horizontal lines. So y equals negative 5 and y equals 3 are perfectly horizontal. So if I were to graph these just as a visual, if I were to graph these guys, y equals negative 5 would be a perfectly horizontal line down here at negative 5, and y equals positive 3 would be a perfectly horizontal line up here. So you can clearly see that those guys would be parallel, okay? And even though this one looks a little weird, right, this one looks a little weird because I can guess that some of you guys are going, how am I going to check my answer there? Well, there's no x in this one, right? There's no variable for the x. So even though I have an x coordinate, there's nowhere for me to plug it in the equation. The only thing I can plug it in here is 3. And I know this looks weird, but if I plug in 3 for y, I get a true statement. So it still works, even though that's kind of a weird looking one, okay? And the last one we're going to do for the parallel lines, because I think that'll be sufficient for this video, is we're going to go ahead and look at number 4, because that one's also a little weird, because the slope is actually negative 1. So if I look at this, I still want a line that's parallel, which means I'm going to keep the same slope. and my slope is right here. X is not the slope. Repeat after me. X is not the slope. The slope is only the coefficient that is in front of the x. So here, my slope is -1. So I'm going to use -1 as my slope. I still have x sub 1 and y sub 1. I still need to use point slope form. And when I plug it in, I'm going to get y plus 3, because there's a minus sign there. This is a -3, this is a minus sign, so I'm going to plug it in as positive 3. My slope is -1. X minus 2 goes in parentheses, like that. So now I'm going to distribute, or as you know I like to say in class, distribute. I'm going to distribute the negative, and you don't have to put the -1. Again, I wouldn't mark you wrong on a test if you did that, but we really don't put the 1 there. It's invisible, it's understood to be there, so kind of get used to seeing that. So I'm just going to put -x, and then -1 times -2 is going to be a positive 2. I'm going to carry down what I have there, and if I compare this to my slope-intercept form that I'm using as a reference, I can see that I've got one more step. I got to bring that 3 over. So I'm going to subtract 3 from both sides. Those guys are going to add up to 0. And here we go. -2 minus 3. Yeah, that's totally going to be a negative right there. I caught myself. And we can see that that is definitely slope-intercept form. So if I want to check my answer, because we've checked each one, we're not going to stop now. If I check my answer, I know that these two lines are parallel because here we have a -1 as the slope. Here I also have -1 as the slope. And I'm just going to verify that this line does pass through that point. And to do that, I'm going to plug it in. I've got a negative. Be careful, that's a negative on the outside. And then there's a 2. Order of operations takes over here. So we've got -3 on the left. And then this is implied multiplication here. So that's going to be -2 minus another 1. And that's going to give us another true statement. Perfect. Okay. So just to sum up what we did here, when you see these types of problems, and let me tell you, you're going to see them on your test, you're going to see them on your EOC. It might only be one, but you're going to see it. Okay. So when you see problems like these, the important thing to look for is, do they want perpendicular or do they want parallel? They both start with a P, so be careful. Read when you're taking your tests, okay? If they want a line that is perpendicular, you are going to find the opposite reciprocal, which means that you're going to take the given slope, you're going to change the sign, positive to negative, negative to positive, and you're going to flip it. Okay, so 2 over 1 becomes 1 over 2. If, let's look at this example. Let's look at this one, right? If they want a line that's parallel, then you use the same slope. Okay, so if the given slope is -2, you use that same slope. If the given slope is 0, you use that same slope. If the given slope is -1, you're going to use that same slope if the lines are parallel. From there, the process is the same. You plug it into point slope form, distribute on the right, add or subtract 1 on the left, and you're done. And you can always check your answer if you need to. Hope this helps.